Okay, so on the next page, we have a new one, a political claim, or I'm sorry, a political expert claims that 60% of Americans believe government regulation of business does more harm than good. So this is a percentage one. So for H sub O, P is equal to zero point 0.6. You question this claim and wish to test it. Doesn't say less or greater, so we're just simply going to say P is not equal to 0.60. You select a random sample of 1,762 adults and ask their opinion. So we have a sample size of 1,762. Of those people asked, 1,004 believe that government regulation does more harm than good. So we're going to test at alpha is 0.05. So wants to know what is the value of p hat. Well, again, p hat is just equal to x divided by n. So we're doing 1004 divided by 1762. So the answer that is best going to match here is going to be my 0.57. Okay, so then we want to know the p-value. And again, guys, I am all for running these in the test, or these tests in the calculator, because you get your answers very quickly and easily. You don't have to worry about, it's a two-tail test, so we have to multiply it by 2. We don't have to worry about that. So this is a one prop z-test. So in my calculator, I'm going to go to stat, tests, one prop z. So my null hypothesis was that it was equal to 60%. X was 1004. N is 1762. We think it's not equal. And so there, very, very quickly and easily, we get a p-value of 0.0097. Okay, so then number 7, which is the last one to go along with this, calculate and interpret a confidence interval. So if we run a one prop t test, then to go along with that, we want to run a one prop, I'm sorry, I meant a one prop t test. Then we want to run a one prop z interval. And all of our information will already be in there, so we just have to go to calculate and we get our interval. So 0.55 to 0.59. And I'm going to use it as percentages in this case. So we are 95% confident that the true percentage of Americans who believe government regulation of business does more harm than good is between 55% and 59%. So I know it doesn't ask on this one, but what decision would we make? Based on our p-value, which is less than 0.05, and based on our confidence interval, which does not contain the original, which was 60, that tells me that in this test we would be able to reject the null. Okay, questions 8 and 9. Now, these are ones that you will probably want to have your formula sheet for. Let me grab mine real quick. Okay, so on this one, it gives us our null and alternative. So what you're looking for here is, because this is not equal, this is going to be a two-tail test. It says you calculate a test statistic, and because it says t, this is specifically a two-tail t-test. So we've got a test statistic, we got a sample size, we want to know what is the p-value. So this is your crucial information for looking at your formula sheet. So I want to make sure that I'm looking at the t-test. We're trying to find a p-value, and it's two-tail. So we're going to do TCDF. We're going to follow our formula, and then because it is a two-tailed test, we have to multiply by 2. So in this case, we have to use the formula sheet and do this by hand because we don't have enough information to run the full test in the calculator. So my formula sheet said that I'm going to do TCDF. I'm going to do my test statistic to E99, and then degrees of freedom. So degrees of freedom is 1 minus my sample size, so 29. And then because it's a two-tailed test, I have to multiply it by 2. So in my calculator, here's what this is going to look like. Second bars TCDF 1.25, not that, to infinity, degrees of freedom 29. I'm going to get this answer and then multiply it by 2. So I have a p-value of 0.221. So that is going to be option A. Okay, so now for question 9, you wish to test H sub O mu equals 8 versus, these should both say H sub A, sorry about that, mu is greater than 8. So this tells me this is a one-tailed test, and we calculated test statistic Z, so this is a one-tail Z test. So there's our information about where we're looking on the formula sheet. So I'm now on the Z test side. So now with this one tail, I actually need to be a little more specific even. So because it's greater than, then I know that this is actually a right tail test. So to do a right tail test, we're doing normal CDF, our test statistic to infinity, 0 and 1. So normal CDF 2.18 to infinity, 0 and 1. And we don't have to multiply by 2 here because it is only a one-tail test. So 0.0146. So that's going to be option B.